Hello, Johnny Long here. I'm in the slightly odd position of reading out an advert about how we have no adverts on Escape Collective. Now, I don't think all ads are evil, but I definitely prefer our little world to exist without them. Our website is so clean, and our podcasts are blessedly free from any messages imploring you to buy some green gloop that would definitely make its way through your system quicker than the time it took to put your credit card details in to buy 6 months worth of the stuff. The trade-off here, in order to keep things nice and pure, is we need you, yes you, the person listening, to sign up to become an Escape Collective member. That's the only way we can make this membership-funded model work. We don't have to go with our begging bowl to marketing executives like the vast majority of cycling media do. I will not drink the green goop. You can't make me. If you are already a member, thank you so much. You are appreciated beyond words. And if you know someone who's on the fence about signing up, why not give them a friendly little nudge? Hey, if we sign up enough members, maybe I will drink the green goop after all. Go to escapecollective.com/member to sign up.
Welcome back to the Geek Warning podcast. My name is Ronan Laughlin, and, well, I'm hosting this episode because this is not a regular episode, but rather a deep dive special episode into Wilier's new Supersonica TT bike. And now, before you switch off because you're not interested in time trial bikes, I urge you just to listen a little further because this episode might be of interest, regardless of what type of cycling you enjoy. Almost to their own surprise, Wilier has a new time trial bike. The Italian brand already had 2 time trial bike offerings in the Turbine and the Turbine SLR. And so when they signed the dotted line to supply Groupama FDJ team bikes on a multi-year deal, a third time trial bike was far from an immediate priority. That was about to change though, and what ensued became a race against the development clock to design and build a new bike for the race against the clock, and specifically for Stefan Kung. The end result of that race against the clock is Wilier's new Supersonica SLR, first raced by Stefan Kung at this week's Tour de Suisse opening prologue yesterday as I'm recording this. The new bike was developed in just 4 months and has ditched the camtail and truncated tube profiles that have dominated cycling design for the past decade and sees the return of true NACA profiles throughout. It features an integrated seat post. Wilier are offering custom aero extensions for all, and as a result of acclaimed 50 hours of simulations, 30 hours of wind tunnel velodrome and outdoor testing, including CFD and wind tunnel testing 5 leading competitor time trial frames, and, as we're about to hear in this podcast, the result of countless late nights and weekend hours. Kind of have to mention the price as well, in that a frame alone cost €9,000 and a complete build with Durace and Mieke wheels, plus those custom time trial extensions, costs an eye-rotting €27,400. Now, you might be wondering why there's a dedicated podcast to this new time trial bike. Well, that's because Wilier give Escape Collective and myself exclusive access to follow the development of this new bike over the past few months and to kind of tell a story of how a time trial bike is developed, why a UCI rule change meant that the water bottle ended up costing a whopping €22,000 alone, and all the testing that goes into ensuring that a new bike is actually faster for Stefan Kung. Key to the entire design was Marco Genovese. Marco Genovese is Wilier's head of design, and I sat down with him to record this episode of the podcast a couple of weeks back now during the Giro. And while we obviously will discuss the new Supersonica quite a bit, what I wanted to delve into with Marco, given his 14-year history and having developed over 100 different frames, I wanted to speak to him and get an understanding just what the design process of a new bike looks like. I was kind of curious, was it a case of sitting down with a pencil and a sketch pad and drawing out new designs that might end up making it into a new frame, or what the modern process looks like? As we'll hear from Marco, this process for designing this Supersonica was incredibly limited in terms of time that they could dedicate to developing the new frame, so not entirely representative of every frame's process. But nevertheless, Marco gives us a fascinating insight into just the entire process behind developing, designing, testing, proving concepts, and everything that goes into producing a new frame. And so without further delay, let's hop across to that podcast with Marco Genovese, head of design at Wilier Triestina. Marco Genovese, welcome to the podcast. Thank you for joining me here today. No prizes for guessing what nationality you are. I'm a big fan of Italian names. Both my kids have Italian names, and Marco Genovese, I think, if I'm pronouncing that correctly, I think is one of the nice Italian names I've heard.
Yes, correct. My name is Marco Genovese. It's correct.
You're joining us today. You have a design position with Wilier. Do you want to just briefly introduce yourself? What it is you do with Wilier?
Yeah, I started to collaborate in Wilier in 2010. And believe it or not, I started with a time trial bike introduced in that period for a Lampre team, special TT bike with a very strange shape with the double foils on the fork. It was the first experience to work of my job with Wilier, and it was a big challenge for me. The bike was very good also for the particular patents that we introduced in that period. We was one of the first brands in the world to introduce the total fully integrated cable routing. It was the 2010s. Of course, in that period, we were young for the informations about the aerodynamics. So the contributes were still little, was just very simple, not the improvement for the speed. But the frames was very stiff. A lot of riders use it. In the end, the bike was a good successful for Wilier. So I was very happy for that moment. And now after that, I started my career with Wilier and the design of Wilier.
So what you're saying is that you were one of the first to incorporate fully internal cable routing, and maybe those who don't like that can maybe have a question with yourself.
Yeah, it's important this point, this characteristic respects, because there were just two other brands of the other competitors who introduced that kind of innovations. And believe it or not, in the same period, in just 3 months, we saw 3 patent pending from different brands. Every patent was very similar, but with some different characteristics. And that allowed for every competitor to use his patents and use the bike with the cable routing inside. Because one of the important innovation was the cable through the headset. That was the important story. After that, Wilier improved a lot of these respects, because they introduced also for the road in the road bike the internal routings in 2015, if I remember well, with a specific headset designed by me and by Wilier teams, produced a special bearing made just for Wilier.
That internal cable routing is it's commonplace on pretty much all performance bikes these days. And you mentioned, your first project with Wilier was a time trial bike, and that's what we're here today to discuss, is the new Supersonica time trial bike that you've been heavily involved in. Before we delve into that, I just want to get a bit of a background from yourself also. Like, was it always your ambition to be a bike designer, or how did you end up in this space?
If I started from high school, you don't believe it, but I studied in the artistic high school. Okay. Then after that, I continued to studies for design, industrial design. Sorry. But after 3 years, I was not happy for the information. So I decided to make the crazy idea to start the university in engineering materials. And after 5 years, I get the graduate for engineering. So after that, in 2005, I started to work in industries. The period, in the university period, it was for me very difficult because, starting from artistic high school, I didn't have the tools, the informations for the maths, for physics. So I'm not able to go in the university for engineering university. But thanks to the continuous loop with the sports, and particularly with the practice triathlon, because I practice a lot of triathlon, I got the rhythm to studies and stay always focalized on my goals, sport and and engineering in that period. After 5 years, I was happy to reach the graduate of the university. In 2005, I started in bicycle industries because, I was a passion of the bike thanks to the triathlon with my focalized attentions on the materials, on composite materials. I found a good position like R&D assistant in one of the Italian brands. The main, maybe you remember, it was the Fondriest brand.
Yes.
And I started to collaborate, to work in that factories. I stay with them 4 years, and I developed many frames with them. First, just like assistant in R&D, because in that period I was not ready to start the designing. But after a couple of years, they charged me to start with the design of the foundries and some frames that for road bikes and truck also. And then was born my story.
We've caught up now to when you started with Wilier in 2010. Is it just coincidence that your first Wilier project was a time trial bike, given your triathlon connection, or have you a special interest in time trial and triathlon bikes?
When I started to work, I was a passionate of the bike, of course. But after a couple of years, when I learned to make the design, to make my job, I became passionate of my work. It became for me a very, very passion for the kind of job, because, the bicycle industry is always in changing, continuous changing about materials, technology, innovations, specs, of course. 2010, 2006 also, it was easier than now because, of course, there were just a mountain bike 26 inch, a little standard bike, and the road bikes. Nothing else. Yeah, okay, of course, some time trials, but it was very easy in that period. But in this period, everything is changed. There are a lot of kind of bikes. And I believe for me, big lucky because I can make something different every time. So, of course, my passion remained the road bike because, I practice road bike and NTT bike also. But also in a mountain bike, there are a lot of things to explore for me and for the Wiliers. We are got a good results from the current teams of mountain bike. We are very happy for the results from Mondetto. And we got a lot of feedback from that team. Yeah, my passion continues until now, and I'm very happy and lucky for the situation that I'm living now.
You mentioned how bikes have changed in that time, almost 20 years you've been in the industry. How has the actual bike design process changed? Presumably a lot?
I think that the method is always the same. I think the bone of the method, the core. Because you have to see also the competitors, what happens, the innovation from the other brands and other products, of course. And you start to think about the new idea, new exploring. You have also R&D to manage. So R&D is activities totally parallel from the designing. So we have to invest a lot of time in R&D. And when we are ready, you transfer in the design. When I started, it's not so changed so much. It isn't changed so much. Sorry, It changed a lot the innovations. So thanks to the new generative algorithm that you can use with CAD, with 3D programs, you can introduce some interesting tool to improve, for example, the aerodynamics. Of course, if we have to talk about the goals that we have to reach from your design, yes, you have to introduce a lot of tools and new information that comes from the innovation of the softwares, of course.
I'm curious, does the initial idea, the initial concept, does that originate in those software programs you just mentioned, like CAD, or is that still you have an idea in the shower and then you come out and you grab a pen and paper and you draw something that then becomes a bike at some point?
Sometimes, as you saw from Supersonica, we didn't have many time to develop it. So it was very important to start directly with the right idea. To have the right idea, you should have a lot of experience on your background. Sorry to say, but I think that I got a lot because currently I have more than 100 frames designed by me. Thanks to these opportunities, Supersonica was born well in the right direction. As you told me, there were some tools like a CFD that can help to make your job. But it's important to start from a good position, good point.
Yeah, I think there's maybe a misconception that CFD tells you what to do, or parametric design, you can use that and it just gives you an answer. But the key input is the sort of parameters that you're asking it to work around. Is that where your experience can really help with that process?
You have to match the specs of the bikes. So every kind of specs that the teams, Wilier, so the factory wants. And also to find a combination of good results with the performance that you have to reach. When we started the Supersonica, it was for me a nightmare, very nightmare, because, when we started to collaborate with Groupama asked us to develop a new frame. After the test that they made with the current frame, Turbine SL, they were not so satisfied about the results. They wanted more efficiency from aerodynamics. It gave me a very short time and also a goal to improve of 10% of the current frames. Wow, how can it possible? It was impossible for me. I had just 4 months to develop the design. 4 months, I mean, because in 7 months we provided to Stefan the first roll bike. It was very impossible mission, let me say, but we got these results because we were lucky to got the right idea immediately, maybe. Of course, as you know, some important innovation that we introduce is the use of the integrated seat post. It's helped a lot because the integrated seat posts allow us to reduce a lot of the cross sections. Cross sections was one of the most important specs to reduce the drag, of course. And another important thing that we already have more experience, it was the use of NACA 00 profiles. So NACA profiles was the key to got as good successful of the results. Thanks to these specs, these characteristics of NACAs and choice of the products, we got a good results compared to the other TT bike, I mean. And we reached the goal. It's incredible, but we reached the goal.
For those who haven't seen it, there will be an article about the new Wilier Supersonica time trial bike on escapecollective.com, probably around about the same time as this podcast. So have a look at that to get a better visualization of what we're talking about here. But one of the first things that struck me about the Supersonica when I seen it back in February, I think, one of the prototypes, was those NACA profiles, which you've just mentioned, which, I mean, initially when the cycling industry started focusing on aerodynamics, those profiles were commonplace. But for the last 10 years or so, most manufacturers seem to be moving to truncated and camtail profiles. And now we've done or Wilier and yourself have done like a 360 and or a 180, and we're back with these NACA profiles. Do you want to explain the thinking behind that? Is it only on a time trial bike that can work? And what are the pros and cons of that using those profiles?
Yes, you're right. I think 10 years ago, yes, some competitors introduced this special profile truncated with the truncated tail, which named camtails, from the name of Vani Balkam, the engineer who studied this particular shape. This solution is very good to have a good balance between aerodynamics and stiffness. Because, one of the most important things is the stiffness of the bike. But if you have a shape, a cross-section, which doesn't help to get a good stiffness. You can get the risk to have a very flexible bike. Maybe you see also in our first prototype that we got some problems with the seat tube because the seat tube was too flexible due to the cross section. The cross section was very thin, but it was the first prototype. After a checking and changing of plybook, the laminates, data sheets of the material composites, we improve that kind of problem. And we improve a lot of the stiffness of the pipe. The camtail was a good solution for that period, but after the last studies with the yaw angles, the big yaw angles, the new specs requests, we had to come back to use a traditional profile. And the traditional profile is a complete profile like the standard NACA, according with the standard NACA.
My understanding of the benefits of the truncated and the camtail profiles is the stiffness, which you've mentioned. There's also a weight saving compared to a full profile. But as I understand it, there's also something in the stability or the handling of the bike, especially in crosswind conditions. Is that something you had to consider when reverting back to the NACA profiles?
Honestly, I don't see this in wind tunnel and the CFD, but I saw that the difference using the traditional profiles. Also with the big yaw angles till 15 degrees, complete profiles is complete profile. With the tail without the truncated shape is the best solution, of course. If the running by cam solution can be applied to the airplane, maybe also the aeronautic use the truncated shape, but it's not true. Currently, also in the aeronautics continues to use the traditional NACA profile. Not NACA, but something similar.
The NACA profiles being much deeper, are they better able to harness the sail effect?
Yes, that's right. For the sailing effect, you increase the lateral force. It's increased a bit lateral force, but it could save you also when you have save a lot to keep attached the boundary layer. So especially for the low speed like ours, 50 kilometers per hour, the Renault number is very low, it's very little. And for these strange conditions, it's very important to have a good boundary layer around the sheets of the tubes and the bikes. So yes, the truncated profiles, I repeat, is a good balance between performance, aerodynamics, and stiffness, of course. I had to save the aerodynamics like requested from the Groupama, and the bike is now is a good success thanks for these solutions. Of course, the new bike is heavier than the old one, but for the team, Wilier can provide both bike, one for the short events, TT events, for nervous events, with the parts where you have a lot of accelerations. Of course, you can use the previous turbine SLR. But for the speed, for high speed, for long ways, the Supersonica is the best, of course.
You mentioned after the initial prototype testing that there was a stiffness. You needed to add more stiffness to the seat post, the integrated seat post. Is that just more carbon in the layup, or how do you achieve that extra stiffness?
Change the fibers. Let me to explain. For the stiffness, it's easier than the aerodynamic studies because, of course, it's more linear the job of the engineering process. The stiffness is the products of the cross sections, the moment, the inertia of the cross sections, and the material characteristics, the Young modulus of the materials. Thanks to the experience, I know what were the limit of the cross section that I could use it. I got a plan B when the first preliminary plybook was not okay, using particular carbon fibers. Carbon fibers that we introduced is not a secret, is M46J.
So yeah, just a change of fiber, effectively.
Yeah, yes, of course. Initially, we started with a T700 in every directions. But for the 0 degree, we prefer to use JB, because now it changed the name. Thanks to use this kind of fibers, we improve the stiffness. So I don't remember if 12 or 15%, but a lot of contributions just for changing the fibers.
On that note, presumably you've seen a lot of development work in the use of carbon fiber in your 20 years in cycling industry. Are we reaching full understanding of how carbon fiber works, or do you think maybe the cycling frame design is still somewhat limited by how well the cycling industry can use carbon fiber?
It's a good question because, I think that in terms of materials, we reach a plateau. There is no new innovation about the fibers. At the end, the resistance modules is the same in these last 10 years, 15 years also. Because I remember about the M46J, my favorite fibers for a good compromise from modules and resistance in 20 years ago when I was a student. Nothing is changed now. It's changed a lot of the process, of course. What is changed is the process. The process to produce the frames are usually the same. So there is a mold, there is a preliminary laminates parts that you put inside the molds, and thanks to the bag, you push a lot of pressure and heat and curing the parts and transform the composites in something of solid. This is the method. We improve, the industries improve a lot of this kind of solution. The industry started to introduce the internal molds, some special molds to keep the materials more aligned before to go inside the molds, the main mold. So it became more accurate. The process became more accurate than the original process. And thanks to this, you can reduce the value of the distributions of the safety of the products, no? Because you have to guarantee that 99% of the Gaussian curve affects the target that you imposed. But if you have a big distributions of the values, you have to use a lot of materials, a lot of cross sections, a lot of weight. At the end, a lot of weight. But thanks now to these innovations that you can get a more accurate process, you can reduce the Gaussians and with a better performance. I saw this changing in these last, especially these last 5 years.
I guess that comes from just a better understanding of how best to use the material and use the molds and the manufacturing process. I know one thing you talked a lot about with the Supersonica was the use of double walls.
Double walls is another solution to improve the stiffness, of course, because if you introduce the mold, the wall inside of the tubes perpendicular to the flat surfaces of the profiles, you can increase the stiffness. Why? Because you increase the resistance to the buckling. There is a strange phenomenon which name is buckling. When you have a very thin foil, you can pull it a lot, but in the compression is very fragile because there is a problem create the buckling. But if you introduce a wall inside, you solve the problem, of course. The stiffness, because you increase the inertia, local inertia of that area. This is a new, very innovative solution that we use thanks to the use of the new technology with the particular use of the foam inside, like the PU, PS, and other combines between that solutions.
You mentioned that the specifications that Groupama had given you in terms of a more aerodynamic bike were beyond anything you had targeted before. Do you think there's still some development capacity remaining as teams focus more on aerodynamics and less on weight? I know for Astana, it was very important to have a lightweight time trial bike. For Groupama, they seem to not care so much about the weight and more focused on aerodynamics. Does that give you more flexibility?
Yes, I think that we just finished the Supersonica, and I'm sure that the next question will be to reduce the weight, of course, because every time when you make something of new, is already on the. Of course, this is our story. Currently, our plan is to provide them both frames. I think that Wilier is the only one brand for which supported the World Tour. We can provide two different frames for the TT bikes. It seems a strange story, but why not? It can be the solutions for many different events. If you have a very short race with a lot of changing, rapid changing, of course, you have to evaluate very well the weight and get a very, very lightweight, very light frame. If you have a very long street, like for the next Olympic Games or for the next world champion, for TT events, of course, you have to think about just the speed. This can be our solutions for the World Tour team.
I guess the best example is the Tour de France time trial last year, which was downhill and flat time trial at the start, and then a climb to the finish where maybe a lighter time trial bike is better than changing to a lighter road bike.
It's like the road bike, of course. We had to introduce two kind of road bike, one super light and one aero bike. I think that could be the same story for TT. If you want to make a balance for both requests, yes, you can do it. But maybe it will be not the best for every event. So maybe it's time to think about it, to have two different bike.
Obviously, one trade-off for getting more aerodynamic is increased weight. But if we forget about the weight for a second, are there any other risks in chasing all the aerodynamic gains you can possibly achieve? Are there any imbalances or handling concerns, or is there anything that being too aerodynamic can be a negative? Specifically in the frame, I mean, if you can get more aerodynamic, presumably you go faster, but is there a trade-off in the other ride characteristics of a frame when you make it aero?
Honestly, for the road bike, we didn't find any things to change about, for example, for the geometries, we don't change nothing, just a little bit. We corrected the stack and reach specs for the new bikes according to the new handlebar that we will introduce it. I suppose that if you got a good balance between stiffness, comfort, of course, and aerodynamics and weight, of course, these are all the components more important to evaluate the bikes. So,
could you use the same NACA 00 profiles on a road bike? Would that be okay?
It's not possible because in these bikes is more important the weight. So for the TT, you can reach 1 kilos at 100 grams, no problems. It's acceptable. But for the road bikes, on the base of our experience, also for the aero road bike, it's very important to keep less than 1 kilo, of course. I think that in the future, also for the new product that we will develop, the new aero bike, which maybe replace the Finante, will be very important to stay lower than 1 kilo, of course.
Everything we've just mentioned, you have to do within the UCI regulations. How much of a challenge is that?
With the UCI, there are always many problems because, the rules are not perfect. So sometimes happen that you can read well the rules, then try to start with a sketch, with idea, and then happens that the idea is not and it's not possible to adopt because commissioners say that it's not good according for the rules, but where is wrote, you don't find any information, and every time you have to make a ping pong with the UCI to get the approvals of the preliminary. Believe it or not, for the Supersonica happened that we got, let me say, the approvals, the preliminary approvals from the commissioners. And then at the end, he told me that it was okay. After he wrote, okay, it's a big problem. I know it's very difficult to plan the rules of UCI. I imagine that there are a lot of problems to when you manage the rules, adapt the rules. But just for the Supersonica to explain my experience, they introduced a specific rule for my bike. What's happened? Sorry, I don't understand because it was incredible. We made something not so original because in the Supersonica, the big innovation was the integration of bottle, right? The bottle and bottle cage. They decided to introduce a specific rule for my case. It's incredible.
Those types of bottles exist on other time trial bikes.
Yes. One of the most important TT bike today is the TT1 of Conago. Conago made a very good product. We got the test also because we tested also the competitors before to make the Supersonica. It was very important to test the most important TT bike on the market, but specific for the World Tour team. Conago was one of the best bike that we tested. And we saw also make a scanning, 3D scanning of the bike and make a simulation that the big goals was the integration of the bottles. This was one of the important innovation that they introduced in the market. We saw the results. We saw also what we can do. And when we introduced the drawing and the UCI, the preliminary drawing was okay. But after a few months, when I requested the official approvals, they rejected the print because it was not okay. Okay, this is a strange story, but I can imagine that it's not easy for the commissioners reply to you because I suppose that there are a lot of innovation every time. It's not a secret if you allow me to say that in 2010 I was in the commissioner. I was a commissioner of UCA. I was in the commission for the KeepMed in the period of Julien Caron. Julien Caron want to in charge me for commissioner because I was the only one professional guys from the industrial. It's incredible, but I was the only one, and I helped a lot of the commissions to solve the problem. But in that period, there was the starting contribution of WFG, the World Federation of Sport Food Industries, and they requested me to left my positions because it was not possible, of course, that I was a designer for the brand and also commissioners in UCI. There are these strange situations. Of course, I decided to continue to make the designer, but sincerely, opinion was to solve the big problem before there are a lot of problems, and I was in charge for solve the problems about the rules and the strange conditions. For example, one of the most important rules that I tried to introduce, but I didn't reach, was the safety for the bike. Because, there is no rule in the competitions about the condition of the limit of the safety of the bikes. Okay, this is another story. I can continue a lot of time, but it's not a focus on the products. But just to reply, just to conclude, problems with the UCI is very difficult to adapt the rules on the new innovation. I can imagine that it's very difficult for the commissioners.
I think not to go too far down that rabbit hole, but the idea of a safety test for a bicycle rather than a minimum weight limit, which was initially designed to be a safety factor with the bike is 6.8, it should be safer. I think in this day and age, in 2024, a test of that safety would be better than a set weight limit.
For example, now the UCI introduced a request to the teams to have the ISO standard approvals of the bike. But if you read the ISO standard says that it's not usable for racing for the race event. They should be passed and copy, and they make very specific standards for the safety. They mean the UCI, of course. They made something for the wheels. There is the impact of the wheels, very super strict rule because the impact is without the tires. So But of course, it's better than nothing, of course. And as you know, just in this period about the problems with hookless, mini hook, with tubeless, there are a lot of problems around the wheels. But coming back to the questions, the safety, I think that should be the priority currently for UCI and not the problems with the integrated bottle cage or other devices. They should improve a lot of these points, I think so.
That's probably a subject we could dedicate an entire podcast to. So maybe we come back to that another day. You did mention there competitor analysis on all our TT bikes. That was part of the wind tunnel testing, if I remember correctly. Can you talk us through some of that competitor analysis and also some of the wind tunnel testing done on the new Supersonica?
Okay, about the wind tunnel, before to make the wind tunnel, you have to make the CFD because you have to evaluate how is your trend of the values about the CDA, and understand if you are in the right direction. Then the wind tunnel is a big problem. Why? Because the problems of the wind tunnel is that every wind tunnel has their own signature. What I mean for the signature, the turbulence factor, because it's impossible to have the perfectly continuous fluid on the testing chamber. You have just a little turbulence on the flow. This condition can be a little problems with the test because you can get the absolute values of the CA, but you have a values specific of that wind tunnel. For example, for Supersonica, we got the test from Silverstone, and I think that it will also for the next seasons of wind testing our place where we conduct our tests for the road bikes or other products we need aerodynamics, and the wind tunnel from Milan, the Polytechnic of Milan, and the values are totally different. Not only the values, but also the trends.
Okay.
And this is a big problem because the tuners has different turbulence factor. To solve the problem, how can you do? Because it becomes crazy when you saw the data. There are two solutions. The immediately is make the average value. You have to make a lot of CDA, according to different U angles. You got an average values of the most important angles according to the average values in the world for the wind, because there is a specific articles about that. And get average values, total average values. And you evaluate that values from the CFD, from the CFD. CFD can get the same and you get the values. These data are more interesting in different speed also. And you can get a trend of your CDA and a trend in the wind tunnel and also in CFD. And you can see that the trend can be similar. Another method can be testing the turbulence factor, because you can test it. You can use the sphere. The sphere is a body very known in literature, so there are a lot of data about the sphere. Mm-hmm. And there is a particular condition at 300, if I remember, 380,000 Renon hammers, the critical conditions of the sphere, and his drag cut a lot, fall down. And you can evaluate the difference from the theories and the practice, and you get from that the turbulence factor. Turbulence factor, you can use it in a CFD, and you should have a similar condition over your computer, your analysis by computer. This could be another solution. It's not easy to do it because the sphere you have to have a very good instrument. I see this instrument in a wind tunnel of Newton in Italy. I was very happy to collaborate also with them because they have a very good experience for the data acquisition, and the quality of data. But at the end, what's happened? Wind tunnel gave you a values, and as I told you, is not the same that you have in real way in real life. in the world? Yes, of course. You have to be able to catch the trend. This is the rule. You have to be able to catch the trend and understand what's happened before and after the innovation that you introduce. So, of course, you have to plan testing of old products, other products also, like I told you. If you catch the trends of these products, you can get the right benefit also for the real work.
You'd mentioned that the signature of a wind tunnel can be different or will be different between two different tunnels. If you just take one tunnel like Silverstone, is the signature the same every time you go back, or are you also having to use the test to evaluate each day?
Silverstone has been for me a good surprise. I'm very happy to collaborate with them. For many reasons. I think the first one is the quality and the quantity of the data that you can collect in one stage. Because, for example, last year I went there 6 times or 7 times, I don't remember. A lot of time. Yes. And I collected also a lot of data for the wheels, because for us it's also important, the wheels. And believe it or not, but in just one day, we collect more than 800 runs of the wheels. Wow. So a lot of data. But the most important things, like you asked me, you suppose it, the quality is good because we tested a benchmark in the same conditions, speed, same SOYO angles, and we got an error, an average error less than 0.4%. Very little, very good. I'm very happy. Yeah, Silverstone is an Eiffel wind tunnel, right? There are 2 kinds of wind tunnels in the world. Göttingen, the closed circuits, and open circuits, which name is Eiffel, like the Silverstone. The Eiffel wind tunnel should be not so accurate like the Göttingen circuits, Göttingen wind tunnel. But at the end, for our goals, our business, it's a very good surprise. Good surprise. Cool. I don't tell you, but Milan, for example, Polytechnic of Milan, the biggest wind tunnel supposedly in Europe, is fantastic, of course, because they have a Göttingen circuit. But the Göttingen circuit is made for upstairs. You know how it's made? It's a circuit with downstairs and upstairs. They are very smart and clever to make 2 testing chamber. One upstairs, biggest and huge for bridging, for building. And that window, that testing chamber is very good for that reason. Indeed, they built that building for the bridge on the Sicily, in Italy. But the second testing chamber got a flow not so accurate. The second chamber is downstairs. And we got, as I explained you, very different values from Silverstone, and also different trends, very strange, different trends comparing also the city. I don't want to say you that Silverstone is better than Milan, but Silverstone CFD, we got the same trends. So for this reason, I plan my activities in Silverstone.
Yeah, it's more representative for your other testing, your CFD or your outdoor testing, and that's where you've seen the value. Is that correct?
Yeah, that's right.
You did also have a mannequin of Stefan Kung in the wind tunnel. I believe had Stefan himself in the wind tunnel at some point, and then you also did road and velodrome testing with Stefan. I was at a lot of those testing sessions, not all of them, but I was wondering throughout if at some point the aero testing with Stefan or the feeling that Stefan got started giving some bad results, what would have happened then? And were the results positive, I guess, is the first question.
See you next time. See you. So this is my reply. So there wasn't a plan B. We tried to do the best. Mm-hmm. We were confident that the data was good. There were no problems about the new frames. Also, the test that we conducted in Italy for the stiffness, for every protocol that we got in our experience. So we were very confident that the bike was better than the new one, than the old one. If it happened something wrong for him, it was very difficult to plan immediately first of all, a new design, a new product. As I explained you before, in 7 months from the request, we got afraid. We didn't have any other plan, and not possible to make any other solutions.
Did you hit the 10% that Groupama had requested?
Not yet. They requested 10%, and now with the average value, we are over. We are at 12.5%.
Is that a 12.5% reduction in the CDA of the frame or the drag force on the frame, or what's that reduction on?
This request was for the bike, complete bike. Without extensions, but with according with a specific request of wheels and other devices like big chain ring, chain wheel, and Shimano group set. When we use the mannequin, of course, this gap is reduced a lot because the body can be a big difference. Considering that in terms of CDA from the testing of the mannequin, which pedals, and the bikes, there are 7 or 8 times of CDA. So if you got 12 with the mannequin was 1.5, 1.6% the difference. But this gap is very important. If you try to make evaluations, just tell you that I can improve 1% of your CDA in 30 kilometers of race, you can get 20 seconds. You can save 20 seconds or more.
Yeah, I think you had made the calculation that Stefan was third in the Tour de Algarve time trial in February, and had he had the new bike, he would have been second and much, much closer to Remco. Wasn't it Remco that won that stage? I think so, but you had made that calculation, yeah?
He arrived third, right?
I think so, yeah.
Yeah, third. Yeah, I calculated that he got, with the new bike, second place. I made it that calculation.
I guess he'll be hoping for first place in the races coming up with Tour of Switzerland now, Tour de France, Olympic Games, and then a home World Championship. So I'm thinking for him, it's good the plan A seems to have worked out because it's a big year for him. Yeah,
what I can say, I hope that Stefan can arrive with a good preparation and good training. Now he has, I think, all the best that we can make now for the equipment for the bikes. Talking about the group set, of course, there are some details to adjust, like from the Giro, Ineos introduced the classified wheels. Yeah, I saw that wheels until 2 years ago, and I imagined immediately that it was the right wheel for the TT events. Confident that it was the good wheel. Using for example the single chain ring and classify can increase a little bit the quality of the CDA, but we should make some tests. I'm not so sure.
Hey folks, Ronan here. I'm just interrupting the podcast for a second to let you know what we're going to do to try and make our podcast better for you. We're conducting our first listener survey for everyone who listens to the Geek Warning podcast, and we want to know what you like about this show, what you think needs improvement, what other podcasts you'd like to hear from Escape Collective. Your input helps shape the direction of this podcast itself, as well as the others we create in the future. All of your information is kept private and is used for the sole purpose of making us and this podcast better. Head over to escapecollective.com/survey now to leave your feedback. And, well, I promise it won't take long, but hopefully it will help us ensure that we're delivering the kind of podcasts that you want to listen to. Thanks. You had 7 months to design the new bike. If you were given more time...
No, sorry. I got just 4 months.
4 months. Okay. Okay.
At the 25th of December, I had to deliver to release the final drawing for the molding.
Wow. Okay.
25th of December, I delivered the molding, and early September I started.
Yeah, the question was going to be, if you had more time, what would you do different?
Perhaps I could work more time on the CFD. If I should change something now, maybe I try to find other solutions around the shape, the front fork. I try to investigate in the fork head tube because the front triangles, half bike is very super important compared to the rear parts. Like after the BBE, there is a lot of rumor and a lot of noise. If I should investigate again around the front, should be interesting. Because like I told you, one of the most critical points for our products is the low Renault numbers. We got a lot of information thanks to the big efforts made by the NACA, National Advisor Committees for Aerodynamics from USA. Thanks for the big job, but you know that every profiles are improved. Other kind of Renault numbers. They started from 200 until 200,000, Renault number to 750,000, if I remember. Mm-hmm. That range was focalized for their reason on the airplane and other kind of vehicles. We have the same problems of aeromodelism. The passionates on the aeromodelism, they try to make the scale of the airplane, but it's not possible to do that. You can make something similar of the body, but the wings you have to shoot to change it because it doesn't fly. You should improve, changing a bit the cross sections and make something different because your Renault number is very, very low.
Is the Reynolds number for model aircraft similar to on?
Because if you imagine, I don't know. Honestly, I don't know. I don't want to say something was wrong but I'm not an expert of aeromodelism. But I suppose that usually, I think that they reach 200 kilometers per hour. I suppose an aeromodelism. Okay, there is also something more speed, more faster than 200 kilometers per hour. But I suppose that they can reach 200 kilometers per hour, no more. And they have a very little cross sections, more little than our cross section. So more or less, they have the same problems of the cross section of our elements of the bike. Both, bicycle and aeromodelism has very low Renault numbers. Coming back to your question, the problem is these very low Renault numbers. And there are something very interesting in the nature, like some birds, some bugs, insects, that is strange, but they are able to fly. This according to the rules of the aerodynamics. and why?
That's the bumblebee. The theory is that it should not be able to fly.
Yes, this is the story. And indeed, there are a very particular strange mechanism in aerodynamics, like the von Karman vortex. Mm-hmm. That if you are able to induct the vortex in particular shape of the vortex, you can get benefits. I'm not sure, but someone from the competitors, I don't want to say the name, they started to introduce some interesting aspects about that. We started to study and introduce strange shapes on the elements. Maybe studying some effects on the nature, in the nature.
On the helmets, I thought maybe you were
on the bike. I saw the
seat
but
post.
I don't tell you who is it.
Can I guess? Is it on a seat post?
Yes.
Seat tube, maybe seat tube.
Seat tube, yeah, correct. There is something strange there, but maybe they get inspirations from the nature, maybe.
do you have a favorite bike that you've designed of all the bikes you've worked on?
Now the argument is hot because, Supersonica, it has been a very big challenge for me, 4 months to get that bike. I repeat, I was lucky because it was for me a flash. I was immediately got the right idea and I go fast very immediately to realize the drawing and the prepare the sketches and everything else. So Supersonica is one. For many, for example, in 2012, we introduced one of the first road aero bike, 2011, sorry, for Wilier. It was 101 Air. It was a very super aero road bike with very huge tube sets, according, of course, with various air rolls of that period. Yeah, it was very good bike, and we keep there for many years. The Wilier keep the frame main in productions for many years. Until now, should be a good bike if you change the specs from caliper to disc brake. Another bike that I love it a lot is a Gran Turismo. Gran Turismo, I love it a lot because it was born in the COVID period. I was at home and I designed the particular micro suspensions, micro damper between the 60s and the lug of the C-tube in that period. The bike for me is fantastic because with a full suspended frame, very micro suspension inside of the frame, and it works very well. After the first experience of the previous model, which replaced by the Gran Turismo, this new bike was very fantastic. We decided to made that solution for an endurance bike. Luckily, we were not able to propose the same bike also for racing because the balance of the weight, the performance was not so good or not so adapted for the request of the racing bike. But for me, it was a very fantastic bike.
The other question I had was, and I guess it's not going to be possible given the time that you've worked in cycling, but do you have one signature design item that you add to a lot of your bikes or all of the frames that you design? Is that something?
I think that every bike born like a normal job, let me say, because I'm happy just for the good feeling that I have with the other colleagues. I think that we are a very good team. And, when the feeling is good between every people works around the project, you can make very good products. I think that this is the philosophy for us. So every time when we start for new projects, we share together the information. We make a lot of brainstormings naturally, so very easily. And I think this is the secret, I think, of our results. Of course, I am the designer. I am in charge of the development of the products. But at the end, I think the results of the products for Wilier is the combination of the good job with the other guys who helps me to develop the products. And like Claudio, for example, like Ricardo and Davide. So I think that we got a good feeling, and this is the great philosophy of design that we have. I think so.
Well, I think that's a good spot to leave it there. A nice note to thinking of the rest of the team there also. And thank you, Marco, for the insight you've given us today into the design process. It's something I'd been curious about for a long time, and you've certainly given me a better understanding.
Okay, thank you too.